Question 12. Question 11. Determine the kinetic energy of a circular disk rotating with a speed of 60 rpm about an axis passing through a point on its circumference and perpendicular to its plane. The circular disk has a mass of 5 kg and radius 1 meter. Okay, so according to the question, determine the kinetic energy of a circular disk. Disk is nothing but it is like a CD. Okay, so like this. If it is this CD like shape, okay, it is rotating about its center, for suppose. Okay, so then here they want to what? According to this data, the circular disk is rotating with a speed of 60 rpm about an axis passing through a point on its circumference. Okay, so in circumference is means like this. Okay, this is the circumference and which is perpendicular to the plane. Okay, so not to through the center of mass. Okay, it is moving about its circumference means, for suppose this is a disk. If it is disk and one axis is passing about center of mass, we all know that. Okay, so one another axis which is passing through the circumference, this is our circumference, and which is perpendicular to the plane. This is the plane of the disk, and for this it is perpendicular. Okay, so then now we want to find out the kinetic energy. Okay, so if this is the what I, and that I we want to find out here. And what is the kinetic energy of a rotational motion or circular disk? That is kinetic energy in rotational motion. Rotational motion, we know that that is equal to half into mass into omega square. Okay, so mass is nothing but here moment of inertia. This is kinetic energy of a rotational motion, or when it is rotating about axis. Okay, so then this I is nothing but here uh, moment of inertia of the disk when axis passing through the circumference. Okay, like this, when this is moment of inertia about this axis, maybe it is moving rotating like this. Okay, so then now we want to find out that I and also omega. Omega already here given, that not omega is given, so it is rotating with a speed of 60 rpm. 60 rpm. Okay, this is number of rotations, that is how much? 60 rpm. Okay, so it is equal to 60 rpm is nothing but 60 rotations per minute, and that is equal to here uh, per second, this is rps, 60 rotations per second. Okay, this is our n. Okay, what is the omega? Omega is angular velocity, and that is equal to 2 pi into n. In one rotation it is completed 2 pi, and in n rotation this is 2 pi n. Okay, so that is equal to 2 pi into, this is n is equal to 60 by 60 rp seconds. Okay, means this one is cancelled, and it is equal to 2 pi. Rp second is nothing but 2 pi radians per second. This is omega. Now we want to I. So omega we got here, that is equal to 2 pi, and I. I is equal to, it is a moment of inertia when axis is passing through the center of the disk, that is I naught. For the disk it is equal to I naught is equal to mr square by 2. Okay, so here moment of inertia about any axis which is passing parallel to the axis of when axis passing through the center of mass. So that's why here we have to use the parallel axis theorem. So from that parallel axis theorem, this is the distance. The distance between the two parallel axes, it is nothing but radius r. Okay. So from that, according to parallel axis theorem, okay, by parallel axis theorem, okay, so then I is equal to I naught plus m into b square, means I is equal to I naught is equal to, it is already in our data, that is mr square by 2 plus mass of the disk. Mass of the disk is m, okay, and distance between the two parallel axes, that is r square. Okay, this is according to the parallel axis theorem, moment of inertia of the disk about any axis, and which is equal to, if you are taking the LCM, this is 2mr square plus mr square, that is equal to 3mr square by 2. Okay, this is moment of inertia, and if we substitute the values, we got this is 3 by 2, and mass of the disk is given here, that is 5 kg, and radius is 1 meter. Okay, mass is 5 kg and radius is 1 meter square. Okay, 1 meter square is nothing but 1. Okay, and that is equal to 15, 3 5 is 15 by 2. This is the moment of inertia. And now kinetic energy, in rotational motion, that is equal to half into I omega square, and it is equal to half into I is equal to 15 by 2, it is kg meter square. Okay, so 15 by 2 into omega, omega is equal to 2 pi, and this is 2 pi whole square, and this is equal to 15 by 4, 2 into 2 4, and this is equal to 4 pi square. Okay, so from that 1 4 1 4 cancel, and it is equal to 15 into 3.14 whole square, and that is equal to 15 into 3.11 square 14 square is equal to 9.8 something. Okay, and that is equal to, so the multiplication of these two is equal to 147 something, that is joules. This is the problem. Actually it is not 12, it is 11. Problem 11. Yes, it is 11.